Hello everybody, welcome to Waves Lesson 2. This lesson is about the wave equation. For this lesson you will need a pen or a pencil, piece of paper or something to write on, and you can use a calculator if you want to. If you don't have these things, pause the video and go and get them now. We start the lesson as we always do with a little mini test on stuff you've done before. Here are the questions. Pause the video, write down your answers, and then press play again and we'll go through them. Let's see how you got on. A longitudinal wave is one where the direction of vibration is parallel to the direction of the wave travel. You could have had forwards and backwards instead of parallel. You could have said the direction of the wave or the direction of the disturbance or direction of the energy. Likewise, for a transverse wave, the direction of vibration is perpendicular, I would have accepted right angles, to the direction of the wave travel or energy or disturbance. Frequency is the number of times it repeats or the number of cycles per second. The wavelength is the distance between where a wave repeats or the distance between peaks. A cycle is one complete repeat of what a wave does. Period is the time taken to do 1 second. If you got those right, well done. Let's have a look at a picture of someone doing some surfing. Now you can imagine the situation here. Obviously this wave here is moving in that direction there. It's pushing him forwards. That's why he's moving. That's the whole thing about surfing. Behind it, you've obviously got a number of waves going up and down, up and down. So you already know from last lesson the idea of the distance between the peaks is the wavelength. The amount of times it goes up and down per second is the frequency. In actual fact, the frequency here is going to be much less than 1, isn't it? Because it's going to go up and down sort of like once every 5-10 seconds. The speed this person travels would be the speed at which the wave is pushing forward. So that would be the wave speed. There is a relationship between the velocity of a wave, the frequency of a wave, and its wavelength. And that is velocity equals frequency times wavelength. Velocity is essentially how fast the wave is traveling in the forward direction. So that is measured in meters per second. Frequency is measured in hertz. Wavelength is a type of length that's measured in meters. Scientists don't write out velocity equals frequency times wavelength every time. We use symbols to represent them. So we use V for velocity, F for frequency, and lambda, that Greek symbol that you're introduced to last lesson, lambda for wavelength. 2 key ideas to record then. The wave equation in both forms, you need to write them in your book now. Pause the video. Let's use our wave equation to do some problems. Here's our first one. A radio transmits at a frequency of 98 million hertz. Radio waves travel at 300 million meters per second. What is the wavelength of the radio? So how do we solve this problem? The first thing we do is write out our wave equation. V equals F times lambda. Then we highlight the things that we already know. So we know 98 million hertz, that's our frequency. We know 300 million meters per second, that is our wave velocity or our wave speed. And we are trying to find out wavelength. So we've got our things to substitute into our equation. We substitute those numbers in then. So we get 300 million equals 98 million times lambda. Now we don't want 98 million lambda, we want 1 lambda. So what we need to do is divide both sides by 98 million. So let's put that in, divide by 98 million, and that will turn the problem into that. Now 98 million divided by 98 million is 1. So lambda equals 300 million divided by 98 million. Now the problem you'll have, unless you've got a fancy scientific calculator, you'll probably find certainly the basic calculators we use in the lab very often only have 8 digits. You can't even get the top number in. So what you need to do is cancel out the zeros. in the same way as 10 divided by 10 is the same as 1 divided by 1, and 100 divided by 100 is the same as 1 divided by 1. All you need to do is knock off the zeros. So let's take off these two zeros here, and we can keep working our way along, knocking off pairs of zeros until we've run out. So we can knock off those two, knock off the next two, and the next two, and the next two, and the next two. So all of these have been knocked off in pairs, get rid of the first two, the second two, and so on, till we get 300 divided by 98. So there we go, 300 divided by 98 is what I can type into my calculator, and the answer I get is 3.0612, etc., etc. I'm not going to write that down as an answer. I'm actually going to round that to 3.1. I'm going to go to two significant figures because they went to two significant figures up there in the problem. Now, wavelength is a distance, so it's going to be measured in meters. So we find, last thing we do at the bottom there is we add in the unit. So the wavelength is 3.1 meters. One for you to have a go at now is another wave equation problem. Very similar method, just slightly different numbers in there. So pause the video, have a go at this. So let's see what you should have done. Well, you should have started off with the wave equation. Then you should have highlighted all the things that you know in the problem. You know the frequency, 103.2 million. You know the radio waves, the velocity is 300 million. And we're trying to work out wavelength. So substitute that lot in. And once again, we've got to divide by this big number here. This time it's 103.2 million. So we're going to divide both sides by that. And that's what it looks like. Obviously, these two things cancel out, so that disappears. It just turns into 1. So we end up with that. What we need to do now, all these zeros, we need to cancel them out. So let's do that one and that one, 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 that one and that one. And we've run out of zeros. So this time it's 3,000 divided by 1,032. That's what we're going to type into our calculator, and that's going to come out as 2.9069, etc., etc. What we need to do is to round that, and we're going to once again go to two significant figures, and we're going to add in the unit of meters. You've got that right. Well done. Another problem for you now. Slightly different. Have a look at this. It's problem's slightly different, but the method of solving it is going to be more or less the same. So have a go at this. Pause the video. So let's see what you should have done. Start off, as always, with the wave equation, V equals F lambda. And go through the problem and highlight the things that you know. So we've got a frequency of 0.6 hertz, a wavelength of 1.2 meters, and we're trying to find out the speed or velocity. Substitute those things in. So V equals 0.6 times 1.2. Multiply that on your calculator, 0.72. Add in the unit, meters per second. That's what you should have done. You've got that right. Well done. We're going to finish this lesson off with a little mini test. So another little problem for you to have a go at. Here's the problem. Very similar to the last one, but some different numbers and things, but a similar sort of method. Pause the video. Let's see what you should have done. You should have started off with the wave equation, V equals F lambda. You should then go through the problem and highlight the things that you do and don't know. So you know the frequency is 0.8 hertz. You know the wavelength is 1.1 meters. You don't know the speed. That's the unknown. That's what you're trying to find out, the speed or velocity of the wave. Substitute that in. V equals 0.8 times 1.1. Do the calculation. V equals 0.88. Nearly there. Just the unit to include, This unit is going to be meters per second. If you got that right, well done. If there's anything you're not sure of, feel free to rewind the video. But otherwise, that's it for today. That's all, folks.